Lesson 7, FET Amplifier. Section 7.4. Carriers and pinch-off voltage. The major question in this section is, what is in the input circuit? If the DC voltage VGG is applied across the gate and source, and also across the gate and drain, and VGG is negative, then the PN junctions are reverse biased. Depletion regions are formed on both sides of the PN junctions. In this figure, only the depletion regions on the N-type semiconductor side are shown. If the DC voltage VDD is applied between the drain and source, and VDD is positive, then the electrons in the N-type semiconductor, which are the major carriers in this region, are attracted to the drain. This movement of electrons means that the current ID flows from the drain to the source. The relationship between the voltage VDS and the current ID is represented by the ID versus VDS characteristics. This is the curve at VGG equals negative 0.1 volts. While VDS is in the range encircled by the ellipse, ID follows Ohm's law, because there is only an ohmic conductor in the channel. R is N-channel resistance. If the absolute value of VGG is increased, the depletion region becomes thicker, and the channel for ID becomes narrower. This increases R. And this was the ID versus VDS curve at VGG was negative 0.2 volts. R actually increased. The term field effect is used to describe this transistor, because ID is controlled by the electric field, associated with the reverse bias depletion region. You will learn what electric field is in electromagnetism. In the region where VDS is high, ID becomes saturated. What is happening in JFET in this region? The voltage at the source electrode is 0 volt, and the voltage at the drain electrode is VDD volts. Due to this voltage gradient, the reverse bias voltage applied to the PN junction also has a gradient. The thickness of the depletion region increases with the bias voltage, as shown in this figure. With higher VDD, the depletion regions come closer to each other. At a certain voltage, they meet, and the channel closes. This condition is known as the channel being pinched off. If VDD is further increased, the area where the depletion regions meet widens. The voltage VDS at which the pinch-off first occurs, is called the pinch-off voltage. In the region where VDS is higher than the pinch-off voltage, ID saturates. Do you remember the question at the beginning of this section? It is about what is in the input circuit. The answer is that the input terminal is open-circuited. Because the PN junctions, connected to the gate, are reverse biased. IG contains only the reverse current, which is in the order of nanoamps. Therefore, IG is negligible. Section 7.5. Equivalent circuit. This is the equivalent circuit of a JFET amplifier. The input circuit is open, and the arrow pointing to GM-VGS indicates that the current source is controlled by VGS. Exercise 7.5. This is your homework. Pause the video, and answer the problem. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.